and 8. Good evening, dear participants. We now proceed to day 4, session 7 and 8 of ATAL online FDP on microplastics and emerging pollutants, which is an unsolved, undefined problem. So let us invite Dr. T. Naveen Reddy to introduce a distinguished researcher, Dr. B. Srinivas.
A very good evening to participants and dignitaries and also my fellow colleagues. I'm very happy to introduce Dr. Srinivas Ballakanti. He is presently working as a scientist B in River Regeneration Division at a Central Water and Power Research Station, Pune. And he has completed his master's from Osmania University, and he completed his PhD from Central University of Hyderabad in 2017. He also worked in the area in the field of nanochemistry, polymer chemistry, and novel design and development for photocatalyst for water and wastewater treatment. And he has numerous publications in a very peer-reviewed journals. With this small introduction, I will hand over the session to Dr. Srinivas. Sir, the session is yours, sir.
Yeah, thank you, sir. Thank you so much, Sir Naveen Reddy, sir, and Saraswati, madam. Is my voice audible, sir?
Yes, sir. Yes, sir. It is audible, sir.
Yeah. Okay. So, thanks once again for this invitation. Mostly, I think in this 1 hour and 1.5 hour duration, it's like mutual. Like I will ask many questions. If in this way, I want to involve everybody with not only just putting switch on. They want to involve what question I'll ask, how many members they will respond. It will be more helpful, and for me also, like it will give more enthusiasm to present. I hope everybody will cooperate with this, my dear participants and faculties. Whenever you want to discuss, you can switch on your mic and you can ask any question, not like at the end of the session. I mean, for me, anything is okay. Based on your convenience, we will continue. And by
Okay, sir.
Yeah, thank you. And the screen itself, you can understand like microplastics as an emerging contaminants. Why the title is like emerging contaminants? Because recently this is evolved. So emerging contaminants, they have categorized microplastics. If you understand that background of my title, one plastic bottle is degrading, it is producing, it is generating microplastics, and the fish is eating. I hope you understand this picture. So we'll go one by one. Before going into details, these are my contents. We'll cover these things in the further 1 hour duration. As sir said, I have finished my PhD in University of Hyderabad, where I have did R&D, research and development only. But now at CW&PRS, we are doing applied research. Like this transition from R&D to applied research.
Okay, sir. Start, sir. It's a small disturbance.
Yes. So you will see that R&D, everybody, I think 99% of the participants understand R&D. Now we are doing applied research. Mostly 99% applied research only we are doing. The R&D means like we will work on in the laboratory only. We'll spare our most of the time and we'll continue our reactions. But now we'll come to the field. Here applied research means field.
Sir, go ahead, sir.
Yes. So let me give brief introduction about my organization, CW&PRS. CW&PRS established in 1916, and 2016 it celebrated centenary celebrations also completed. Means 100 plus years of experience industry organization. See, CW&PRS will have major disciplines like 7 disciplines. Applied research, why I mentioned means it's completely like if some area one dam need to construct means our team will go there. They will check geophysical, earthen conditions, and water conditions, seepage conditions, how, and ports. Somewhere in the ports means how we here one location, new location. If one port development means our team will go, and earth and river rejuvenation, hydrometeorology, and all applied earth sciences also, and mostly high-end instrumentation facilities also here we have equipped. Why I am showing this screen, because I think mostly engineering background students also will be there. That's why if anybody interested, you can go with these disciplines. You can check if any your projects also in future, you can check these things. It will be very useful, because here everything like applied research, not R&D research. You will get more exposure towards the real time problem. Now we'll slowly come to the our topics, like annually how much is the state-wise plastic waste generation? Any guess? Place plastic waste generation annually.
Almost like a 20,000 tons or something like that. I'm just guessing.
Yes, sir. Yes, sir. Guess only. That's why I kept guess only. So yeah, good one, but a little closer, sir. You'll see the in the next slide. The Ministry of Environment, Forest and Climate Change recently released 2022-23 year data. Annually, plastic waste, not plastic waste generation. State-wise, you can see here, Tamil Nadu is topping 4.13 million tons of waste. This is waste, not plastic. Sir, you have mentioned is plastic. This is waste generation. This much states are contributing wastage in the million tons. So how much is going in the recycling? How much is going in the landfills? And how much is coming to our homes back? So that we have to rethink again. And one more statement recently come across in the Sustainability Summit 2025, very recently, last month only. I hope so, this month or last month. So Bisleri company, they have claimed only 60% of the plastic waste in the India is recycled a year. Officially, they are saying only 60%, whatever the 100% they are generating, 60% only possible for the recycled. But in that 60% is also 100% not going to the recycling capabilities. Most of the percentage is going to landfills only. Okay. What are these I'm showing here? Any guess? Anybody?
Bottle caps.
Yeah,
Bottle caps.
very good, sir. Very well. So, what any color? Why different colors? In every bottle, only water only will be there. No? Any guess?
Based on the recycle cycle number, the color will be opted, I guess.
Sir, any other guess?
No idea, sir.
Sir, we'll see.
To identify like black water or something else.
Okay.
It is depending on the salinity in the water, also gives colors.
Okay. Or any other, madam?
Maybe the polymer type and the color. PET, I think something like color will be there.
Okay. Mostly faculties are answering. Participants. Okay. So we'll continue it. No problem. Sir, in general comment, I want to give one comment. Any water, what you can say, manufacturer, water bottle manufacturer, water companies, Bisleri, whatever we'll take it, Akinle, they will produce bottle only. They won't produce water. For everybody, water is naturally available. They will do their processings. Okay. So you can see here, blue color means it means like natural. Just they will do filtration. White color means processed or filtered. Green color we will see our Sprite and all. So green color means it's that flavored added. Some flavor they are adding. Black water. Black means Virat Kohli mostly. I mean he is the brand for that. Virat Kohli will drink, So black means it's alkaline water. Red means it's like electrolyte enhanced water. So the few only I have listed here. I mean, little more also there. So just to give awareness only. Mostly like it will give complete awareness about how plastic affecting our lives. So you'll understand that. If you look at the importance of water, water is not only important for us. Every creature on this earth is required. Basic requirement after the air, what we breathe. So we have to save, we have to consume less. But as much as possible, higher level, we are contaminating, we are generating pollution. We see here like industrial waste. Major contamination is like industrial waste. And second one is human activities. And obviously climate changes. Climate is changing like we can't predict. So heavy metal pollutions, dyes pollution, textile industries also majorly contributing. Different air pollutions also coming. If you take the wastewater, how much is generating, like 60% wastewater treatment, 65% through municipal wastewater, and remaining 35% industrial wastewater. This picture, I mean, I don't want to read all, but you can understand like the percentages I have shown here. Wastewater effluent treatment plants, how much you can do, but mostly they are not doing there. Now we are in the government sector, we are seeing the real picture of the STPs also. In India, if 80% of STPs are functioning properly, I mean functioning, in that 50%, the 80% may 50% is not functioning properly. Remaining 30% is functioning effectively, which are doing their work. Like 100% means 30% only they are treating. Remaining things they are delivering into the further river bodies. If you see the water distribution on the earth, everybody knows that 1/3 is land and 2/3 is water. But at the end, we will get only freshwater percentage is 3% only. In that also some percentages like glaciers and some percentage in groundwater, like that. So in this picture, what I want to say, we are having very limited resources. We need to do more with less. Whatever it is, it may be industries, it may be agriculture, it may be our daily consumable. We have to do more with less. Consume less water, not for drinking, usage purpose. This is very beautiful beach environment or water body. If you see, I hope everybody like pleasant feeling. But if you open that, you will see the real picture. How inside the any ocean or river body, coastal area, surface water body, upper it is beautiful. But under if you see all the plastic, many areas, 70% of the areas. Aquatic fish also see how it is accumulating through plastic, and tins also going plastic degradation. This is the picture, how beautiful and inside like this situation. Recently, I think last from 5 years onwards only, this microplastics in research organizations award to do research on this, focused R&D, mostly R&D. So many publications you can see Nature also, microplastics are raining down on the partner. And microplastics in woman blood cause the risk of stroke and heart attack. Microplastics in infant milk powder, microplastic pollution in table salt. And in I think previous day, one of the participant asked, "Is there any proof for salt containing microplastics?" Yes, we have many proofs are there. And human exposure to microplastics, and science article also they highlight the microplastics and human health. So like this, many reputed journals they are highlighting, because the level that much varies, worsen condition we were there. I mean, entire the world. In this slide, I want to highlight like commonly used plastic in our daily life. We everybody aware about this. If we avoid these things, we can avoid our next generation plastic free. But already our generation fully also we can't see plastic free world. But these are the things with their polypropylene, polystyrene, polyvinyl, chlorides. These are the things daily we will use. In some chemical formulas, what are the respective bottles or polythene covers, their chemical structures, just to give awareness only I kept here. And how the recycling capabilities of their plastic natural water bottles, and CDs also. All those things are listed here. If you see statistics, if you go for statistics, in 1950, plastic production is like around 10 million tons around. In 20 by 2050, now around maybe 560 around, but in 2050 it will reach 800 million tons, the plastic production. In the upper side photos, you can see the plastic, how there was a generation of the plastic in recent days. In a minute we can produce many plastic bottles or papers or cups or whatever you want. That much infrastructure developed. This is development is okay, but usage also like that. So plastic generation is higher, their demand is higher, their consumption also higher, but their recycling is less. That is the problem where we are lacking. Any plastic bottle, how many days it will take to decompose or degrade? Any guess? Anybody, participants, faculties? No answer only.
20 to 30 years, sir, I guess.
Yes, sir. We can predict like that. It may be between, sir, 10 to 10,000 years also. It may be between. But even though plastics are, it doesn't decompose. It just gets smaller. You see here, it just gets smaller from larger bottle to smaller particle. So now what are the microplastics? Everybody knows, like last 2 days we are understanding less than 5 millimeter size plastic particles called microplastics. And including what nowadays microplastics are in everywhere: water, soil, food, even the air we breathe. In that also, these are the primary microplastics and secondary microplastics. Primary microplastics means they have directly released into the environment. Secondary means they are degrading and forming to the micro size. They are not prepared for the as a micro size. They are forming naturally. These are all secondary microplastics. We will see further how much they are here shown, like how microplastics are produced. And I think first day session, one guy asked how they are generating like that. You can see here. So any plastic material. So in the naturally only they will degrade with sunlight exposure, UV visible light exposure. Obviously, it will mix with somewhere water medium and mechanical degradations. So by accumulating all these processes, macroplastics to micro to nanoplastics will be generated. These are mixing with our aquatic environments, our natural environments. So we are breathing, we are eating also. Here, global release of microplastic to the world oceans, if you see, mismanaged plastic waste is 10 million tons per year. Fishing nets also contributing 0.5 million tons. Fishing nets, you can't imagine fishing net, okay, chalta, aisa will use like that, but that also contributing. And primary microplastics, 1.5 million tons. Road markings, road paint also will give some contribution. See, like marine coatings, synthetic textiles, plastics textiles, tires, personal care products. 35% share for the synthetic textiles. You can imagine that much generating. And some sizes I have listed here. In previous sessions they have explained. If anybody interested, can go ISO 24187. They'll give some information about microplastics and their sizes, how they are categorized. So those things you will get that. One guy asked me one question in one meeting, sir, where we can get microplastics free? But I told only simple, tap water में microplastic है, bottled water, sorry, Hindi I am coming. Bottled water also containing, marine water containing, wastewater containing, even our water also containing. I mean, indirectly everywhere microplastics are there. We have to be more precautious. Three major different hazards. Like if microplastics contain already plastic raw material is also hazardous. In that BPA, bisphenol bisphenol A. So that chemical additives they will mix. That's why children bottle boxes they will write BPA free like that. So if any bottle is hard bottle, soft bottle, you will see that that on the bottle you will read some very low size of the words. You will see the chemical names and the warnings whatever they want to give bottle, right? And plastic, on surface of the plastic chemicals contaminants will be absorbed. These three will create a problem. If you see life cycle of the microplastics, any bottle, plastic bottle, for example, you will go to beach, will roam here and there, will feel thirsty, we will take one water bottle, we will drink, and we will throw. With the flow, with the air, natural air flow, a bottle will go to water, and after a few days it will form microplastics, macroplastics at least. So and then the some fishes will eat. That fishes will come to our plate only, or means human plate only. So indirectly, it's like cycle. It is coming to us back. Whatever we are giving, it will come. So in the three, like mostly human exposure, three like inhalation, skin transfer, and ingestion. Like what we eat, what we inhale, with the exposure also. These three ways are there. Possibilities microplastics for consumption. General, everybody, just to give awareness, typical per capita consumption of microplastics. Soft drinks per ml, 40 microplastics will be there per liter, sorry. And wine bottle also contain, sea bottle contain, mussels, and fish, shellfish, and salt also. This many count microplastics particles are there. This is like studied. Studies reveal these results. This how this in this light you will see microplastics in the air. You can see the dust particles like that, and in ingestion, this number wise we have represented here. Areas of research on potential microplastic harms. Mostly majority of the organs are affecting: urological damage, cardiovascular disorder, oxidative stress, immunological disorders, obesity, inflammation, disturbed stomach, cancers. Whatever the major are the causing the by microplastics also. The microplastic contamination of sea salt. So ocean salt, then ocean salt, and definitely ocean, from there microplastic already contained there. They will come and they will dry, and then will mix with the salt. It will be consumed by people. This is, if you see original pictures here, unprocessed salt, from there to processed salt, both they have checked. They have find that microplastics presence in the samples what they have highlighted. And this is the proof for the FTIR spectrum of the polymer presence, microplastic presence in this unprocessed as well as processed salt. These are like salt packets. Commercial salts also contain microplastics. Nowadays we are using like colored pink salt. Pink salt is like iodine less, not iodine rich. In that we can't imagine, we can't see also any plastic. White means somehow we can say this is white color, and if any other colored compound comes, we can witness at least. But in the small, in the nano size, we can't see. First thing, if you see also micro and nano, if it is mixed with salt, means whitish color, that also will become little white only. So that's why some dyes we have to, for identification in the research organizations R&D, some dyes they are placing to better visibility. As a layman, we will see like we will thought like we are eating daily salt also. I never see any salt like that. We can't see. That is the problem. We can't see. If we were able to see with our naked eye, everybody can simply take it out and keep it. But it's not possible. Just we have to be maintain. Rock salt is better. So alternatives we have to look for. These are some of the studies which exposing this how many percentage of samples present in the sea salt, and grain size, their size classifications, coarse material, medium, and fine, and their mean averages of microplastic size we have represented here. flow diagram for microplastics extraction from the salt sample. Like some quantity of the samples, they will dissolve in the water, and after that some digestion period, after that some filtration, after that visual inspection if possible, after that like instrumentation facilities. So that only we can see complete picture of this salt. These are the some images, fluorescence and some images of the microplastics which are obtained from the salts. So the different microplastics found in the water sample and soil, salt samples. Apart from the salt, human saliva also can contain the microplastics. Can you imagine? No, no. So nearly number of human samples, 2000 samples they have checked. I think this is 2021 by using Raman spectroscopy. Number of particles reported 650. I mean, even one particle also, it is there. Human saliva also contain microplastics. In our mouth also, we are accumulating place for the microplastics. So far that impact of health, it's yet to report. Microplastics from the breast milk storage bags. Breast milk storage bags, what we are going to give for kids. So they are also given identified microplastic presence. So all the blood, lung, placenta, health risk means for women. But for us means, okay, any one organ will affect for kids. Yeah, there is no proof until yet, but definitely it will be major damage for them. These are the pictures you can see. These from the breast milk storage bags. Whereas it is appearing like that, they have separated. So this many thickness are there, and each of this respective polymer shown here in this picture. Whatever they have highlighted, you can see in the same picture like 3 micron, 3 micron, 2 micron, 2 micron, 4 micron. This much sized particles are there in that breast milk storage bags. Human blood, microplastics in human blood also. See, many studies are there. Many studies revealed microplastic presence in the human blood. They have did some studies like digestion of blood sample without effect on added microplastics. Means how they have studied. I will explain that once again. Blood sample they took. They have added microplastics, not like any blood sample microplastics is there or not. They have studied. They have added microplastics and they have did that chemical exposure HCl, HNO3, KOH, basic and basic medium and pepsin and pancit medium also. And after that they have studied. Nothing happened to the plastics. No digestion or particle analysis not possible. And KOH case also effective digestion, but no particle damage. Pepsin plus pancin case also effective digestion happened, but no particle damage. Means particles is staying like that only. If any microplastic surface containing any contaminants, that is more dangerous because it is not degrading. It will release simply heavy metal or whatever it is accumulating on the surface of the body. They will mix to the body and they will release to the system. These are the different number of samples they have taken, and blank samples also they have checked. Mixed plus blank, both, and different polymers. What varieties of polymers you see? This many percentages, 31% PE. So like that, 0.5% of EBC, mixed polymers. This many ratios of microplastics found in the blood samples. One more question to get relief. Why ice float on the water? Anybody from the participants? For chemistry background, everybody knows mostly. Why ice float on the water? Both are water only.
Density of ice is lesser than water.
Okay, good. Good, Dinesh.
Hello?
Hello.
Can you hear me, sir?
Yes, good, Dinesh.
Yes, thank you, sir.
Yeah. So I will show here like the original picture also, how density means it will create void. That's why density will be less.
Small pores are there inside the ice, so air can entrap inside and so it floats.
Yes. Why small holes will be created inside?
Hydrogen bonding due to hydrogen bonding.
Yes, yes. To do hydrogen bonding, there will be void. Void means space. So due to that, we will like float. It will float. Good.
Thank you, sir. Thank you.
Yeah. Good. No, thank you. And one more, if we continue, microplastic sampling procedures. Sampling procedure. This picture we'll see like one is like normal filtration, one is like sewage, uh, mm, and sieve shaker, and one is like net, some net, whatever we use, different sizes nets we can use. Manta net is famous. Manta net will give like lesser size, whatever now if you want to take 5 micron sizes, that much micron sizes net we should use. These are the first three requirements. These pictures if you see here, Manta net, and the first one I have shown here, no? Manta net, and the right side picture is like a real application of the picture. This for water collection, like surface water collection. So mostly what are the difficulties? Anybody will do sampling, but what are the difficulties I'll explain here. This portion, like ironed portion in the Manta net entry mouth will call. Okay, so there sometimes the weight, like it should float and little bit it should go inside, then only some water will flow through this net. This end of this Manta net, one portion will be there, collector. That is very important. Collector fitting, this one major error people will do. It has to fit properly, or else what are the collected samples, it will go back and it will mix with the water body. One, that one. And in the mouth place we should have some little weight plastics, because you will understand, no, if we go to the water body, it should float, but not completely. Some water has to flow through this net, then only the water, whatever the flowing through this contained microplastics will be collected at the end of this mouth. I hope you understand. So while passing the boat, if this required, when we are taking large portion of the area, like surface water, one river, one canal, or one lake, if you want to take, you have to go little slow with the boat. Man driven boat means better. If motor driven means we have to instruct them, go per kilometer. We have to, that also we have to maintain for record or for publication purpose also, how much area we have covered to collect the microplastics, and how much speed we have gone for repetition also, and anything. Then 1 kilometer, around 1 kilometer if we have to go, and after that some stretch, like if you have 1 kilometer stretched surface body, you have to divide by 10, A, B, C, D, E, F, this portion, this much, this portion, this much, this portion, this much. So the practical problems, I'm saying these are the practical problems, since we are doing on this. So practical problems, to avoid that, we have to maintain these small things. Fitting of the net also, fitting when we are fitting. And the net is like now normal, our fishing nets or our mosquito nets. It looks like that only, where net part I'm saying. But it is like lesser sizes, like lesser than 5 micron size. So based on cost, it will cost around 6 lakhs. So based on our budget, 6 lakhs, 2 lakhs, 1 lakh also available. Then size will be matters. What are the your targeted size particles you want to capture? Based on that, you have to take. And while sampling, we have to immediately, the plastic won't come out. Little we have to dry. I mean, dry means not with any temperature, normal natural drying only required. Then only completely we can take out how much coming while opening also. After that, that end portion, collector portion only we have to clean. And in this whole process, we should not use any other plastics on our hands, gloves or anything, because we don't know how much or which kind of plastics will come from what are the items. So from our side, any even forceps also we have to use iron forceps only. We should avoid plastic usage from our side while analyzing and while collecting the samples. These two, I hope you understand that. And next one is graph sampler. Graph mostly plastics. See, plastics, if any particles are there, they will float. Because lighter weight particles, they will float on the surface. So that's why surface water collection purpose, we'll use net, manta net, or similar kind of any net. And graph sampler means any sediment particle. Sediment, if you, this one you see here, this like two hands. It will go and it will collect the mud and it will come out with this rope. We will send that inside the water body where it will touch the survey water body ground. Then there it will collect the sediment and it will come out. That mud, that sediment, we have to take the lab and we have to analyze. First we have to dry it, and regular process. I also kept the slides, and last 2 days also displaying now. So it's a regular analysis process. These graph samplers, all three are graph samplers only. Any type we can take based on our, it will be sold based on kgs. How much kg of sediment you have to collect. Mostly 5 kg is enough. Before above 5 kg, we can't take out. I mean, it will be like more heavy burden while pulling out. These are real-time problems I'm saying. Pulling out, no, so our hands will be little irritation will come. So 5 kg, or if 1 kg also available, you have to take, if you want to more sample, you have to take more times. But don't go for more than 5 kg. So practically, it will be little difficult for us. These two are important for sampling purpose. This is a sampling procedure, sampling and analysis procedure. We'll collect from the one more thing I want to stay here. This manta net mouth portion also we can decide while we are purchasing. Or half meter we have to, you need to have open, or I mean, how much centimeters you want to have this mouth open, that we can decide. Means if you have more mouth open, you can collect more area, so that will be one advantage. And then coastal water surface, any sample will collect, sample collection, collected sample. After that, if wet saving required, digestion required, density separation required. Why we'll use H2O2 and any salt? Because density separation. Just now we saw, if light particles, they will float on the beaker upper, so we can filter easily. The filtered particles we can check by using analytical facilities, microscope or FTIR or Raman or whatever. If you want to check particle size, SEM and EDS we can use. And we can give our observations and we can give our results based on size. What are the sizes of that? What are the types, beads of flakes, and what are the colors? Why, for example, here I will show that. See, microplastics in lakes will collect water and sediment. Two will collect water, and how much volume also we have to decide first for both some water sample and sediment samples. First trial we will bring anyway 5 liter of water, 5 kg of solid sample. What we done that I'm saying. 5 liter of sample, 5 liter of sediment, and we will dry. Sometimes you won't get anything, one or two, because wrong place we may pick. So then next we'll go analyze, okay, multiple places. For one location, 10 sampling pans will take, and 10 5 kg we will collect. It will give good results for us. And this density separation purpose, sodium chloride, calcium chloride, any things we can use. These for floating purpose, they will float on the surface, and we can use for analysis. Purification with wet peroxide, Fenton reagent, acid or alkaline, anything for purification purpose. If any heavy metal or any contamination is there, we will purify that. And identification. First identification is like visual identification only. If anything we are seeing, definitely they will float. No, float means larger sized particles we can see, and after that microscope we have to do. And this is the picture, like visually how much sized particles are there, what are the color, what are the shape. And then microscopy, what will give basic information, what we can't do visually. And then we can go FTIR is fine in my opinion. Whether this sample or this area or this water body have plastics or not. If FTIR definitely will give what are the plastic, polyethylene or whatever it is. The plastic contains, like FTIR will do simply. If anybody can't afford Raman or GCMS, any thermal analysis means anything. FTI, simple FTR is fine. We can do with that. Whether microplastics is plastic is there or not, we can say FTR is fine for a basic research purpose. R&D only. What are the shape? What are the type? This money required for publication purpose. But if you want to do really, we are in the real-time application purpose. So we are focusing, okay, we will go to our nearby areas, Kadakosala Dam, very near for us. We will go there and we will see, okay, this area is contained plastics. That much information is sufficient for them. If we say here in this area, polyvinyl chloride is there, means nobody understand. They will understand only, okay, this body contains plastics. So that much. If real application is when it comes to R&D purpose, then we have to consider all those factors. This image I have collected from the Bruker website. They have also showed clear picture only. So how water sample collected or sediment collected, they have to purify it. They have to go for filtration, normal filtration unit. Or the filter rate, they will check for the microscopy, and it will do plastic presence if it is there. This is there in the Bruker website. Just to inform you, I kept this slide. And these are the different analytical facilities available for the microplastic analysis. Simple microscope, what we can't check with naked eye, and FTIR. Next, Raman spectroscopy, and for size distribution के लिए same, and mass spectroscopy. And it's different like identification, quantification, characterization, fractionation. The different purposes, combined instruments we can use. Nowadays, many of the institutions having microscopes and FTIR, and SEM also, I think so. Mostly Raman and mass spectroscopy little costly. If possible, you can go RS with these three also. We can cover our basic research purpose. Now, what we can do, like how we can filter 3-stage any treatment process, 3-stage required. Coarse stage 1 coarse material they will filter. Stage 2 microorganisms. 75%, 74% of microplastics removed in the stage 2, and stage 3 fine filters. And nowadays nano filters also coming. Nano filters, proper filtration will be. Again, if you go to statistics, microplastic distribution in the oceans. Ocean surface mein ज़्यादा है, 60% in the surface. Deep ocean nearly 25%. And coastal areas around 18 to 20% is there. In the distribution, single-use plastic is 50% single-use plastics, 50% other plastics. Mostly problem for us is from the single-use plastics only. From our side, when it comes to the topic I am saying, from our side, we given a proposal like we should stop all the conferences giving plastic bottle, water bottle distribution. For participants, we will put their water cans and the glass bottle, glass cup for drinking water. So in this also from our side, we people only testing. We will take one small water bottle, one time we will drink and we will throw. So it's like a small initiative our side. People are started here to avoid that. And bags also, mostly conference bags, mostly we won't use. For the sake we will take somewhere. Most of the bags we don't like actually, and if we like we will use, or else it will be laid down in our homes only. So wherever the possible, better to avoid single-use plastics. And others is like global plastic statistics. If you see landfill, it will be 75% and recycled 10% that plastics, and others are 15%. So simple way is like reduce single-use plastics, recycle properly, avoid microbeads products, spread awareness, support plastic bans. These are the small simple initiatives we can take. And now we will come to what we will do here at our division, CW&PRS. As CW&PRS, our division name itself, River Rejuvenation Division. It was in before 2000, before 2000 chemistry division. उसके बाद it got renamed as a River Rejuvenation Division. From the Modi ji initiatives, they have given this name for our division, River Rejuvenation Division. Means their intention is we have to rejuvenate our rivers by giving any inputs. From the when the mostly field investigations only we will do. This one of the study conducted for Bhima River. Bhima River, there this red color highlighted areas, we have collected water samples and we have given our inputs. These are the parameters we will cover for water quality purpose, mostly physical, physico-chemical, except biological. अभी biological expert नहीं है, so except biology, all parameters we will do at present. And Panshet Reservoir also we have collected water samples and they have given water quality studies for us. We went there, we visit. Like these boards, we will go, we'll collect the water sample. We will come laboratory and we will analyze and we will give report to the concerned body. And we will give our report like what are the, in this, if you see here, third point, farmers in the catchment area should be educated about harmful effects, the excessive amount of pesticides and chemical fertilizers. They are in that area, they are using fertilizers more. So what effect of that also we have studied and we have given our inputs. The reservoir water should be treated and disinfected before supplying for domestic application. Agriculture purpose means okay. Domestic purpose means it should be treated like that. And regular monitoring of the supplied water should be carried out to protect water bodies. And after that, field investigations and laboratory studies for assessment of water quality. Ujjaini Reservoir also we have corrected. We have covered around 72 kilometers stretch. Studied and these three Velsrenia, these kind of Econia, these noticed there. And detailed study on biological purpose they have studied here. Ujjaini Reservoir observations. Low primary production we have noticed at Panshet Reservoir due to low phytoplankton density, steep slope, higher rate of water flow and more depth of the reservoir. And compared to Panshet, higher productivity at Ujjaini Reservoir due to availability of more nutrients and favorable physical features. Here the sewage contamination appears to be major problem at that reservoir place. Sewage contamination is a major problem. And during summer at many locations of the Ujjaini Reservoir, dissolved oxygen concentration reduced rapidly. When nutrient contents higher, definitely dissolved oxygen content will be the problem there. In Ujjaini Reservoir recommendations what we have given: pollution controlled at point and non-point sources, provision of sewerage system is necessary, no discharge of warm water to avoid affecting, means the notice like sudden temperature fluctuations. So warm water, some thermal industries or any industries, the warm water will release to avoid no discharge. They should not discharge it to this water body, and effective enforcement for tolerance of criteria for industrial effluents. These recommendations given for Ujjaini Reservoir. And uske baad Sardar Sarovar also. Sardar Sarovar field investigation and laboratory studies conducted and mathematical model studies conducted. And BOD levels, there we have noticed BOD levels higher and we have given our recommendations. Kudrumik also, they have given pre-monsoon, post-monsoon, how they have given like water is suitable or irrigation purpose or not, they have asked us to study. We have studied. And red soil contains significant iron, which is expected near iron mining area, but it is not affecting. We have studied that near this area some mining area is there, so they want to study any effect is there or not. Studied, or seniors have studied that one. And field investigation and laboratory studies for assessment of water quality, Mulamutta River. If you know about Pune, Mulamutta River is one of the major water producer for the city. So, but very, very highly polluted, and we have studied for that. We have given mathematical modeling details also how to reduce the pollution. So, I mean, e-flows. Some days there is no flow of the water. One is pollution is there. Another one is there is no flow. If flow is there, environmental flow is there, pollution will be diluted, and day by day, it can be reduced. So that kind of things we have given. And quantitative assessment. Recently, we have started one more thing like surface water, microplastics in the surface water source of the Pune. This is Kadakwasala Dam. This photo captured by me. Left one A. And B is from the web we took. There is no much data available microplastics on the surface water bodies. Okay, so we want to extend our studies to the surface water body, primarily to the Pune region. And we have selected these 6 lakes for the study in the Pune region: Pavna Lake, Kasbai Lake, Bashan Lake, Manas Lake, Katraj Lake, Mastani Lake. These are their Google image photos.
Srinivas sir, sorry for the interruption.
Madam.
Participants requesting the voice little bit.
Acha, okay.
You
Sorry.
need to rise
Okay,
like
madam.
that.
Yes.
Very low voice like that.
Sure, madam.
Please.
Sure.
Yeah. Thank you, sir. Thank you. Continue, sir.
Yes, madam. And one more interesting area we are working on: in situ water quality monitoring in the surface water source of Pune. In situ water quality monitoring. Other day, one previous day sessions, I asked one question like some faculty mentioned real-time monitoring of microplastics. In my opinion, that is not possible. Until now, until today, that is not possible. Zara also said that only this is not real time. This is cumulative usage of all the instruments like that. But for monitoring water quality, I hope my voice is now clearly audible. For
yes, sir.
For monitoring water quality, we have a real time now in around the world also there real time water quality monitoring. So now I will show you like how real time water quality monitoring. Everybody will know water quality monitoring, or why we have to monitor. First question is why we have to monitor, because for effective management of the any water body, we have to monitor the water body. How we will monitor? In previous days, people will go and collect the water sample and come to the laboratory and analysis, which is laborious, and they will keep in that ice box that water bottle around 4 degrees. Most of them won't maintain proper temperature, and 1 or 2 days delay in the analysis. After that, we will get the water quality data. To avoid that, this much delay is there, no? Around 1 week, you can say. Minimum 3 days. If somebody want to know water quality data in that X water body, minimum 3 days required. But in the 3 days, the concentration may increase or decrease or rapidly shoot up. So to avoid that, for effective management, around the world shifted to real-time water quality monitoring by using water quality sensors. They are commercially available. So they will put this first image. Please follow the arrows. With solar also nowadays they are working. They are deputing water quality sonde sensor. Sonde means it will have 4 or 5 sensors. They will give the data by telemetry. They will pass the data to the systems, and that will generate the data. Immediately it will give access to whoever want to see the data. Whoever want to see, but because the organizations, government organizations, they will give access to the respective states and respective districts and respective laboratories also. They will give at this location, at this point, some concentration is shoot up, and sometimes some sensors won't give any data because it may gone bad. So that kind of things we will come to know with the real-time water quality monitoring. Now this area is also evolving because it is necessary for India, countries like India. Everywhere it is there, but countries like India, we have now Modi ji government is investing huge money, Ganga, Yamuna, they want to regenerate. So real-time monitoring stations they have installed many numbers. I will show in the next slides. CPCB around, they have started like National Water Quality Monitoring Program, NWMP. From this NWMP, from until last year, 4484 stations, around 28 states and 4 union UTs also, they have installed 4484 stations of real-time water quality monitoring. This monitoring will give monthly, quarterly, half-yearly basis. So if you want, you can get 1 minute data also. Now 1 minute, 1 minute data also we can get. This is the growth of the year-wise growth of the water quality monitoring. 2020 it started, and now by 2022 data 4484 stations have installed around the India. This data for India only. And see, we will go to fields like this. We will go to the field and we will check the data there itself. We will come. This image you can see here in the third image. First two are different locations, different times, and two different instruments. So you can see this monitor is showing like at that time temperature, that water temperature, their pressure, their DO percentage, their TDS levels, their salinity, their pH value, their turbidity value, their total solids value. This much data we can get immediately. We no need to collect the water sample and come back to the laboratory, and no need to perform any analysis. This is in situ we'll call. Because why in situ I'm saying it's not real time, it's in situ. Real time means we have to install the sonde there. The whatever there in my hand, it is called sonde, water quality monitor. Full setup is called water quality monitor. That whatever the dip in the water is called sonde. So if we are not installing there due to, I mean, it may stolen this many reasons, so we are not installing, we are checking. At this, whatever the photo I am showing here, we are checking the water quality, in situ water quality data. Immediately we'll get the data. Data will be stored in the device and it will come to our mail also. We can store there also. This is in situ water quality monitoring. And one more thing, in India wise, all the states are implementing real-time water quality data. And NHP, National Hydrology Project. National Hydrology Project recognized CW&PRS as a nodal agency. And this NHP is funded by World Bank. World Bank is funding for water quality monitoring. Whatever the issues are, whatever the problems related to water, many funding, much more funding come from the World Bank. It is distributing to all the states, all the countries. And for us also, for India, we CW&PRS recognized as a nodal agency for sensor testing and calibration facility. Now, previous slide, I have explained about real-time water quality monitoring. For example, they have some states, implementing agencies we call. Implementing agencies, they have installed the, I hope time is there. So, they have installed the sondes. The sensor need to calibrate. For example, vendor will sell one sonde and they will calibrate at a room temperature only, they will calibrate and they will give. Per vendor is like any vendor will manufacture only one kind of sonde. And same sonde, Jammu and Kashmir government took, and same sonde, I mean similar kind of sonde, Rajasthan took. Why I took these two states? Because Jammu and Kashmir temperature is different, Rajasthan temperature is different, or Hyderabad temperature is different. So one sonde need to perform at respective temperatures, means real time temperature, how much existing there, that field. So we have developed a facility which we can set temperature like 5 degrees centigrade to 45 degrees. And humidity also 40 degrees to 40 to 95% humidity. At these temperatures and humidity conditions, we have developed one environmental chamber. This chamber, by using NIST traceable standard solutions, we will test and calibrate the water quality sensors. We will test whether the sensor is working or not. If not working, we will go for standard calibration by using this NIST traceable standards with respect to their temperature, their required temperature. For Rajasthan means around 40, Jammu Kashmir means around 20. And NHP asks us to give 0 degree also. But 0 degree water is not like water, it will be ice. So we can't check that. I mean, sonde also, sensors also can't work that. So that's why we kept 5 degrees okay. 5 degrees to 45 degrees is fine. And these are the salient features of our facility. And we can check periodic testing and calibration of water quality sensors to ensure their data, reliable data only they are getting. because any sensor, any electronic items, we have to calibrate. For example, in our laboratory weighing balance also we have to calibrate. I think this example is for everybody applicable. Like that, in the real time application using water quality sensors, you have to calibrate. So for testing and calibration purpose, we have established this facility. If you see this facility looks like this. If you follow arrow, when open the doors, it will appear like this, and it will have robotic arms inside. Because while testing, there is no human intervention. The robotic arm will take to the respective beakers. They in the experimental setup beakers are there, no? So it will dip in that, and after that it will go to washing tank. Washing tank, it will wash, and it will go to the next parameter. Mostly we will do pH, conductivity, turbidity, and DO. These four parameters sensors, because these are the core parameters. Any water body is pH means pH range is like 6.5 to 8.5. These are all the desirable limit. DO means above 6 is the desirable limit. So these are the things required, basic requirements for the water quality monitoring purpose. For parameters, like this is our master zone day we'll call. By using this zone day only we'll use pH 0 to 14. They have asked, NHP asked, but we kept 4 to 10 is enough. And electrical conductivity 1000 microsiemens, dissolved oxygen 0 to 12 milligram, depth 6 meters tak, temperature means plus 5 degrees centigrade to 45 degrees or 50 degrees also we can do. So this facility also for real-time water quality monitoring we have used. And I want to acknowledge my organization, Central Water and Power Research Station, and River Rejuvenation for the infrastructure facilities, and KPRIT College of Engineering, Hyderabad, for this wonderful session. Because why I am saying wonderful, I love to give speech. I want to speak. I want to tell whatever we know little bit. I want to give awareness to the participants. So that's why whenever I visit to Hyderabad also, I love to give some lectures wherever possible. Last week we visited Chennai. There also we try to interact with the students. So thanks for Saraswati madam and Navin Reddy sir and all other the KPRIT college faculties who are involved in this FDP. Thanks for your cooperation. And finally, thank you.
Thank you, Dr. B. Srinivas sir, for your insightful and enriching the session. So here are some queries. Let me ask.
Madam.
How FTIR can be useful for microplastic detection?
Okay, good question. Madam, detection that all, no?
Detection.
See,
for detection, why, how FTIR will be useful to detect microplastics?
Answer is simple, but how to express, I'm thinking. See, madam, microplastics detection can't be done by FTIR, but any polymer, plastic material, what type of polymer is there in that microplastic or nanoplastic or whatever the plastic, that will give. It can't detect microplastics or nanoplastics.
Sir, extending to that question, my doubt is that how you can make the sample with a IR with this microplastics. Is there any, sampling problem will come now, sir, because percentage of polymer will be high, so it cannot give the peaks at the correct position. Because the microplastics, whatever we are using, it is not grained. It is not distributed in KBR now.
Okay.
If it is distributed in KBR, then we can expect the peaks. Is there any solution to distribute that one in a KBR? So,
solid as such, solid also we can do, no?
Solid IR.
Yeah.
Okay. Solid IR means that is a KBR mixer, no,
KBR
sir.
mixing only.
How it will be distributed in a KBR?
We have to divide the portion of the sample, not like as completely. We have to divide the portion. FTIR as much as small amount we can use.
Yeah. But when we are grinding the KBR with a plastic,
Sir.
so the plastic will not dissociate into small particles. It will be like a it will be like a, so what we can say, it is stretching. Stretch will be there. It is not purely distribution in the KBR. So is that we can get it from that?
Sir, real location collected sample, have you tried?
No. I'm just asking. I did IR samples, but how it can be distributed, that is a problem. Because where other organic compounds, when you add a pinch into the KVR and then we mix it with mortar piston, we can easily
Correct.
distribute. But in case of plastics, it still remains as a particles, as a lumps. So how is it lumps can be detected in IR?
Sir, lumps, sir,
Can I
lumps, no? Hello?
can I speak?
Madam. Yeah, madam.
Yeah, for your question, you can use the FTIR in the reflection mode. In that mode, you don't have to distribute that in the, means you don't have to mix in the KBR. In reflection mode, you can directly get the FTIR of the solid sample.
I think the reflection mode is for the liquids now, madam.
No, you can use for solids also.
Solids.
Okay.
So melt
Thank you.
condition, under a slight melt condition, we can use.
Yes.
Melt again a problem now, madam. Okay. Thank you, sir.
For us, real-time sample, real samples, when we tested, we didn't face any problem because we will use very less quantity. If you are saying bulk means that much big, we no need to check. Okay, we can divide it. When micro and nano size is preferable. Or if you cut our plastic bottle and if you mix with our KBR, it won't give good results. Anyway, now madam told no reflection methods also.
That is basic techniques, sir.
Yes, madam.
Not 100%. We cannot depend on the FTIR.
Yes, ma'am.
So we need to go further techniques.
Yes.
I think so. So one more question, sir.
Madam, tell me.
What are your insights on microplastics and their interactions with organic and inorganic pollutants, as the bonding such as hydrogen, electrostatic, etc. affect the contamination rates as well as analysis?
Madam, this question is like for this many references are available already. One more thing. So to avoid any contamination only, we will do peroxide treatment. So organic or inorganically, it may be heavy metal.
All participants, please mute yourself. Start again.
Just mute microphone, dear participants. Okay, sir. Continue, sir.
Madam, for this, many literature is available. Share the literature also. But to answer this, see, we will avoid any contamination in digestion process itself. Hydrogen peroxide we will use because our aim is to check the plastics for the mechanism, for the electrostatic attractions. Because of that only it will attract, it will provide the surface to the contaminants like organic, inorganic pollutants. To avoid that, so if when you want to study what are the adsorbents, then that will come to the matter. But for our primary importance is like whether microplastics are there or not. Our focus is on polymer side only.
Yes, sir.
Yes, ma'am.
Sir, one more question. How to count the number of microplastics present in that water sample? See, if we have done SEM, FTR and Raman, how to count that number of particles present in those water samples? How to count microplastic particles?
Yes, madam. It is very easy, For example, whatever the sample you have collected, that is 1 liter, 1 ml, that only 1 liter sample you collected. In 1 liter sample, you have sampling procedures are there, no? Based on that sampling procedure and analysis procedure, like all the treatments, some density methods and digestion methods, 1 liter sample. Yeah, how many microplastics are floating? Or if larger particles means they'll float, smaller particles means
Sir,
they will settle.
I'm not asking like that. I have performed FTR, SEM and Raman. In those
Okay.
during analysis, we are observing microplastic particles in SEM and all. What
Okay.
my question is, during the it's like a SEM visualization and all, how to count the particles present in that in that the sample which we have provided to them.
How to count?
Yeah, it's like how many number of particles present in that water sample.
So then it will come, it is not like how many particles present in water sample, how many particles are there in your grid. Correct, no, madam?
Yeah, yes,
Grid
sir.
means
Correct.
Your
sir,
grid,
it's
how
like
much sample you took,
during
how much sample you took, how much sample you have placed on the grid, the which is there on the analysis surface. So for example, nano, I mean surface scanning electron microscopy, we will check some softwares also there. How many, if many are there means we can pick their sizes also, and by physical counting only, madam. There is no instrument will give in this screen this many particles are there, like the physical counting only, visible, whatever the visible, and we by naked eye we are not seeing. By spectroscopy scanning or normal microscopy, it will appear. Then we have to count. Visible count only, madam.
sir, it's like we are going to place only small portion of that small portion of that sample in SEM. So in that way, it's like, for example, I have collected water samples from different locations and I have
Correct.
performed and I have gone through all those digestion density separation
Correct.
through vacuum filtration, and after that I have sent it's like filter membrane sample for analysis, sir. My question is, during SEM analysis, they will cut only little portion of that filter membrane paper and they will be doing that particular analysis. So in that
Correct.
particular portion of filter membrane paper, if it's like microparticles are present, mean they will say presence of microplastic, or it's like so and so particles are there. It's like fibers and fragment filament are present in that. They will say in SEM analysis. My question is, if it's like microparticles can accumulate anywhere, it may accumulate or it may not accumulate in that filter membrane. In that case, I am asking is, we cannot particularly say that. See, it's like by counting, we cannot say only 5 or 10 particles are present in that water in it's like 1 liter or 2 liter sample. In that case, I am asking you, sir.
Correct, madam. Your question is correct. I understand the back what you want to understand. Question is correct. Very good question. But if you want to know, you have to check all the sample. You have to concentrate it. You have to minimize it. 1 liter, if you take as a your reference sample, how many surface microplastics you have, it will be by floating or whatever, you will separate, no, madam. Nanoplastics means we can't separate. Microplastics means we can separate. It will float. All those mechanisms. For example, 1 ml, 0.1 ml, if you collect that 0.1 ml, you have to go for SEM analysis. SEM, Raman, whatever the microscopy, we have to check. Then only you will understand complete number of microplastics in that 1 liter sample.
Okay, sir.
I
Sir,
hope, madam.
One more question, sir.
Madam.
This undeliberate microplastic distribution, which one is better strategy to control microplastic? Point source or point of village? Understand, sir? Source or point? Which one is better strategy to control microplastics?
Studies have proven, madam, wastewater treatments are releasing much more plastic content. Wastewater treatment, because they are not filtering their microplastics, they are releasing. So we can't say source or we can't say point. Now microplastics are everywhere. If you want to stop, if you want to control should start from our end, our side.
That is the only ultimate solution.
Only alternate, madam. Our generation, in fact, our kids' generation also can't see this plastic-free world. Next generation may possible. See, yesterday's literature news I have studied that which one? Some insects are eating microplastics. Their saliva contains polymer bonds breakage chemical. So these kind of inventions are coming. So maybe in future, definitely, hopefully, we can see plastic-free world. But already, whatever the laws happened already required no, for our generation. So now my request to everybody also, don't look for how much polymers are there, what are the sizes are there, how much numbers are there. Just do studies for whether plastics are there or not. That is enough for us. Even for publication also, this lake, go to your surrounding lakes, collect the water sample from nearby 10 location. Same lake, 0.5 आधा किलोमीटर ऐसा 10 locations you collect the samples and you analyze. Then you can build a one manuscript. No need to go for number or no need to go for shape.
What will you suggest for research scholars, ongoing research scholars?
That's what, madam. So microplastics will give very good exposure. See, last year I given talk at a Guru Nanak University, Abhi University. So Guru Nanak College. That faculties also, the faculties immediately they have released like they want to create conduct campaigns for about creating awareness about microplastics. They have told like it's like creating awareness is very important for researchers also. Start with limited researchers only. No, don't look for Raman, don't look for GCMS or any higher end instruments. You can by collaboration also you can do some in Hyderabad many universities are there, institutions are there. So FTIR is enough. Our simple microscope first simple with our eye we can't see, means simple microscope can see 1 micron size particles. Nano size particles we can't see with a simple microscope. Then we have to go for scanning only, scanning electron microscope. So go to your nearby lakes and create one case study about
Sir,
some
one
lake.
more question, sir.
Madam.
Sir, it is well known that microplastics are present everywhere. Then doing research on that, what is more effective in that? Sir, we all know microplastic is present here and there. Even as you said, in saliva also microplastic is there. Then
Correct,
what is innovative in finding microplastic in water samples?
Very good question.
As it is well known fact.
Very good question, madam. Who is asking? Pushpanjali or what? Who?
Yes, sir, Pushpanjali. Actually, my research is on that only, sir. That's why I'm asking. Sorry to interrupt and sorry to disturb.
No, madam. No, madam. It's very good question actually. Our intention also that only. That's why whenever we will visit any lake or any reservoir, any water body, we won't say that thing or this thing. This contains microplastics. We will say what are the different polymers, what kind of polymers it is there. Also, we won't say. Now, world required solution to avoid microplastics or to degrade the plastics. This way, create the focus. As you said, is correct. No need, there is no point of saying, but we can be more aware, create awareness. Acha, this lake is having microplastics. We should not create more pollution. That much awareness, for creating that much awareness, we can conduct case studies or nearby your colleges, nearby your organizations, lakes you can take up and take the studies. But if you want to really, if you have facilities, go for creating the solutions. That way focus.
You are right, sir, because earlier like carbon dioxide emissions, those things are affecting global warming like that. But nowadays by afforestation we may reduce that carbon dioxide emissions, etc.
Correct.
But this is unsolved problem actually. Better to avoid ultimately.
Correct,
I think so.
Yes.
Yes, sir.
Yes,
yeah, we have a nice getchup. Thank you very much, sir.
Thank you, madam.
Now I request Miss D. Manjusri to kindly deliver the vote of thanks for this session.
Sir, can you share your contact details, please?
I will
One more question, ma'am. You were asking question?
Ma'am, I want the contact details of sir. I actually texted in the chat box also.
Okay, okay. Yeah,
I
you
given
can
my
ask,
mail
ma'am.
ID.
No
I given
problem.
my mail ID,
Directly you can ask.
madam.
Hello.
Ma'am,
Thank you,
continue.
sir.
Oh, okay, ma'am. Good evening,
Manjushree,
ma'am.
ma'am. Yeah,
Good
wait,
evening,
wait.
ma'am.
One madam is asking question.
Okay, okay, madam. Okay, ma'am.
Yeah, wait for a while.
Okay, madam.
Ma'am, you can ask the question to sir.
Ma'am, actually, I was telling thank you to sir because he actually texted in the box, na contact details.
Yeah. Of course, sir. Of course, ma'am.
Okay, madam. No problem. It's my pleasure.
Okay, ma'am. Manjushree, ma'am, you can continue.
Okay, madam. Okay. Good evening, ma'am. Am I audible?
Yeah.
Yeah. Okay, ma'am. Good evening, and thank you, Saraswati, madam, for giving this opportunity and for delivering the vote of thanks. And I wish to thank Dr. B. Srinivas, CW&PRS Pune for sharing valuable insights on the challenges of sampling, monitoring, and analysis of microplastics. Your 15 years of field expertise gave us practical perspectives. Thanks also to our participants for their sharp questions and curiosity. Thank you, sir.
Thank you, madam. Thank you so much.
Yes.
Once again,
Thank
Saraswati,
you, sir.
madam. Sir.
Yes, sir. Thank you very much, sir,
Yes,
for your valuable time.
yes. Whenever required,
Really, we will.
whenever I'll visit Hyderabad, definitely if time permits, I will visit your college also.
Sure, sir. Because we need to take some measures regarding this microplastic pollution.
Sure, madam. Sure.
We need your expertise.
Definitely, madam.
Yes,
I love to give
Uh,
lectures.
yeah, thank you, sir. Thank you very much.
Yes, madam. Thank you.
Thank you very much, sir. Sir, kindly share the PPTs, and if you are willing to share your details, mobile number or email
Sure.
ID, because
PPT, some data we
some
can't share actually. Anyway, I will
yeah.
look for that. Some data we can just like government organization, so some restrictions are there. General data I will share. Sure.
Participants are asking your
That's
contact details.
I hope they'll understand. They can contact me at any time. I will share the details also, no issue. But slides, I will think of it.
Yeah, sir, you can edit and you can resend it. Sir.
Sure,
No problem.
Okay, madam.
Yeah, sir. Okay, sir. Thank you very much, sir. Thank you.
Yes, madam.
Dear participants, just wait for a while or 5 minutes. Dr. B. Anantha Lakshmi madam will take another session. Dear participants, don't leave the session because Dr. Anantha Lakshmi Madam also ready to give her lecture.
Ma'am, feedback link will be shared later or this session
No,
feedback?
now itself
Okay.
we can share. That is better, I think so. Where are you working, ma'am?
Ma'am, I am from IPS Academy, Institute of Engineering and Science, Indore.
In Indore.
Indore.
Yeah. I know. Yeah. Thank you for your participation, active participation.
No, ma'am, your whole schedule is really nice and the members are really giving immense knowledge to us. We are actually grateful.
Yeah, thank you, ma'am. Thank you for your positive opinion on this FDP. Thank you, ma'am. Yeah, ma'am. We shared, dear participants, we shared the link for this session. Kindly go through it.
Thank you, ma'am. Thank you.
பசங்க இல்லைன்னா ஃபீல் பண்ண மாட்டோமா?
Dear participants, kindly mute the mic.
Saraswati ma'am, I have texted you in the chat box personally. Can you just please check?
What is this, ma'am?
Ma'am, actually, I texted you regarding the test. Can you just check your messenger, please? Zoom messenger. Yes,
Okay,
Zoom
okay.
messenger. Yeah.
Okay. I request all the participants. Contact details and I couldn't recognize it. Possible, message me in WhatsApp.
Sure,
Personally.
ma'am. Sure, ma'am. Okay, ma'am.
Anantha Lakshmi madam, are you ready?
Yes, ma'am.
So,
Just a second, ma'am.
let me introduce by Dr. M.S. Pal. Now we move on to session 8, day 4. I warmly invite Dr. M.S. Pradeep to introduce our esteemed speaker, Dr. B. Anantha Lakshmi. Pradeep, sir?
Excuse me, Dr. Sarsi ma'am, I am audible?
Yeah, you are audible. You can continue, sir.
Okay. Good evening to all esteemed participants, respected dignitaries, and fellow colleagues. It's my privilege and a great honor to introduce today's distinguished speaker for the ATAL online 6th day faculty developing program.
Not 6th day, sir. It is fourth day. Fourth day, session 8.
Fourth day faculty developing program 2025, organized under the trust area of bioremediation. This FTP is centered on microplastics as emerging pollutants, analytical and monitoring perspectives. Addresses one of the most pressing environmental crises of our time. And to let us into deeper understanding, we are fortunate we have with us young and dynamic, globally recognized scientist, Dr. B. Anantha Lakshmi. Welcome you, ma'am. Dr. Lakshmi currently serving as research assistant professor at Gachon University in South Korea. She earned her PhD in material science and nanotechnology and cancer cell biology from the same university, where her pioneering research and based inorganic nanomaterials unlocked innovative biomedical and environmental applications. The Research Excellence Award under Brain Korea 2021 and Partibaba Golden Medal from the Government of Andhra Pradesh. Her scientific impact is evident in more than 17 high-impact publications in renowned journals such as Materials Today, Chemistry, Life Sciences. At the time when micro and nanoplastics invading not just our waters and soils but even the human body. Scientists like Dr. Lakshmi provide the vision and innovation needed to confront a silent and severe threat. Her journey is one of the residents' curiosity and a transformative global impact, an inspiration for every young researchers and faculty members here. So with immense pride and enthusiasm, let us welcome Dr. Badula Anantha Lakshmi, a visionary researcher, an inspiring academician, and a true catalyst for sustainable innovation. Her session premise ignite new ideas and transform perspective. Ladies and gentlemen, please join me in extending to her very warm and wholehearted welcome. Welcome you once again, ma'am.
Yes.
Yes.
Thank you, Dr. Pradeep, sir, for introducing me.
Ma'am.
And good evening, everyone. And I am so grateful and I thank to the management, faculty, and especially to Dr. Saraswati Garu for inviting me to deliver this session. I will share my topic today. Ma'am, am I audible, ma'am?
Yes, ma'am. Yes. Slides are also visible.
Yes,
you
ma'am.
can continue.
Yes, ma'am. Yes, ma'am. So the topic which I'm going to deliver today is nanoplastics replacement in cosmetic and personal care products. Coming to the introduction of the cosmetics, I would like to tell the definition of cosmetics. These are the substances that are intended for application to the body for various purposes like cleansing, beautifying, promoting attractiveness, or altering the appearance. These cosmetics are prepared by the mixture of chemical compounds derived from either natural sources or created synthetically. People have been using these cosmetics for thousands of years for skincare and appearance enhancement. These visible cosmetics were used by both women and men in and out of fashion over centuries. So some early forms of cosmetics contained harmful ingredients such as lead that caused serious health problems and sometimes resulted in death. So modern commercial cosmetics are generally tested for safety, but may contain some controversial ingredients such as per and polyfluoroalkyl substances, generally we call as PFAs, formaldehyde releasers, and ingredients that cause allergic reactions. So the European Union and regulatory agencies around the world have stringent regulations for these cosmetics. Generally, these cosmetics mainly used for beautifying. Examples will be like makeup products, lipsticks, eyebrow pencils, concealers, etc. And for cleansing, we are using soaps, shampoos, scrubs, toothpaste, etc. And some are for odor fighting, like perfumes, deodorants, and for protective applications like sunscreens, etc. Cosmetic ingredients can range from naturally derived substances to synthetic plastics, generally occurring from natural to plastic options because for certain functions like texture and exfoliation. Plastic ingredients in cosmetics can include physical plastic microbeads, plastic polymers, and plasticizers like phthalates. These are some plastic materials which are used in the cosmetics. Those are polyethylene, polypropylene, polystyrene, and nylon. Consumers can avoid plastic ingredients by checking ingredient list for common plastic names like these. The reasons which they are replaced with these microplastics are like they are cost effective and they have good durability, they are lightweight, and because of their versatility, these are replaced with these microplastics. These are some of the terminologies used in the microplastics. These are the types and the sizes of these microplastics varying range from nanometers to micrometers. Some of the types are like polyethylene terephthalate, polyethylene, high density polyethylene, polyvinyl chloride, low density polyethylene, polypropylene, polystyrene, and other resins. These are used for preparation of plastic bottles and shampoo bottles, and some are for cosmetic containers, and some are for microwave dishes, etc. Generally, there are some plastic policies. The plastic policies in cosmetics includes bans on microplastics, promotion of bio-based and biodegradable materials, and mandates for recyclable and reusable packaging. The key approaches involve designing plastic-free products, implementing take-back programs, and investing in sustainable alternatives like glass, metal, or seaweed-based packaging. The instruments range from government regulations and producer responsibility schemes to consumer education campaigns and collaborations with organizations that facilitate waste management and plastic offsetting initiatives. Coming to the scale of plastic use, according to Central Pollution Control Board data, it shows that plastic waste constituted annually was more than 9,300 tons, consisting of more than 500 types of plastic ingredients, according to the European Union. The most common one is found to be polyethylene because of its factors like abrasiveness, film forming, and viscosity control. Followed by this polyethylene, polypropylene and polystyrene are also used. And the particle size generally ranges from 5 micrometers to 2 millimeters. The nanoparticle sizes ranges less than 100 nanometers. Coming to the exposure of these micro or nanoplastics, according to USA data, generally a person is exposed to 2.4 mg of polyethylene microplastics per day. And in UK, it was measured as 40.5 to 215 milligrams per day. And these microplastics which they are using are mostly from exfoliants. They mentioned in a data like 1 gram of facial scrub contains more than 300 billion nanoplastics. The cosmetics and personal care products are the major aquatic pollution sources also. These microplastics affects the altered growth, feeding reduction, and also some health issues like fibrosis, and they alter immune responses. According to 2015 Environmental Conference, these microplastics are the second most poisonous ecological agents. But there is a research gap which we need to address is the direct skin exposure to these nanoplastics needs future studies. Coming to the sources of nanoplastics or microplastics, generally the sources include agricultural waste, wastewater treatment plants, road markings, marine coatings, and from industries, city dust, household products, personal care, like tires, wear and tear, macro and microplastics. Generally, these can be from primary sources and also secondary sources. The primary sources generally we call them as plastics introduced into the environment in nanoscale form. From the personal care products, many personal care products contains micro and nanoplastics used as exfoliants or other additives. And the industrial products like applications in nanomedicine and nanosensors and other industrial uses can introduce these nanoplastics into the environment. Coming to secondary sources, the nanoplastics are also formed from the fragmentation and breakdown of larger plastic items driven by the environmental factors. And the wear and tear of vehicle tires is also a significant source. And the other sources are like laundry, wastewater, etc. The synthetic fibers from clothing and washing contribute to nanoplastic pollution in water systems. And coming to the degradation of these larger plastics, the larger plastic items like water bottles, plastic bags degrade into smallest fragments through weathering and other sources, and these microplastics or nanoplastics enters into the aquatic forms and into the air. Coming to the characteristics of these nanoplastics, they have larger surface area which affects their reactivity and interactions with other substances. They can readily absorb to the organic pollutants and heavy metals from their surroundings, acting as a vector for these contaminants. They are resistant to biodegradation, leading to their persistence in the environment and potential for accumulation in organisms and tissues. And coming to the complexity of these micro or nanoplastics in the human body, it stems from diverse physical and chemical properties and difficult for analytical detection and measurement, which exhibit distinct behaviors due to their smaller size and tendency to form echocoronas, leading to increased potential for cellular interaction and toxicity. Coming to the exposure routes and adverse effects of nanoplastics on humans, these nanoplastics primarily enter into the human body by inhalation or ingestion of contaminated food, water, and also through dermal contact with cosmetics and other products. They can also cross biological barriers and distribute to organs, leading to health issues such as oxidative stress, inflammation, cell damage, and disruption to gut microbiota. The long-term effects sometimes includes respiratory disorders, neurological disorders, etc. After entering into the body, these micro or nanoplastics targets some organelles like mitochondria, endoplasmic reticulum, and lysosomes. Mitochondria is the major site for cell energy supply and oxidative phosphorylation. Exposure of mitochondria to external stimuli such as these nanomaterials, which is combined with the microplastics or nanoplastics, affects its normal structure and function, leading to metabolic and functional disorders. The endoplasmic reticulum is a subcellular organelle widely distributed in the cytoplasm of almost all eukaryotic cells. It is an important site for protein and lipid synthesis and plays a key role in intracellular signal transduction implicated in cell survival and apoptosis. But studies have not fully explored whether these nanoplastic particles penetrate the endoplasmic reticulum or not. And the lysosome also, it is an intracellular digestive organelle and the site for enzyme activities involved in removal of pathological cellular waste. These lysosomes can fuse with autophagosomes to form autophagolysosome, in which lysosomal proteases degrade engulfed components. But previous studies reported that nanoplastics internalized in eukaryotic cells accumulate in lysosomes, but the accumulation of induced changes in lysosomal pH and membrane integrity ultimately cause lysosomal dysfunction. And coming to the behavior of these micronanoplastics in the human body, they behave by crossing biological barriers to reach the circulatory systems and various organs, leading to cellular damage, oxidative stress, and inflammation. Generally, these micronanoplastics have larger surface area where it can be easily binded with additives and pollutants and enters into the body. They will migrate to all major organ systems of the body, that transforms and distributes overall the body. Coming to the translocation, these micro nanoparticles enter the body by inhalation, ingestion, and dermal contact, as I said before, and taken up by the cells through a process of endocytosis. Depends on the size, the absorption of micro nanoplastics occurs. As the size is smaller, the uptake will be increased. A significant portion of ingested micro nanoparticles are excreted in fecus, but translocation can lead to accumulation in tissues, inducing inflammation, oxidative stress, sometimes cell death also. While the body attempts to excrete these nanoplastics, their smaller size and the ability of the nanoplastic to bypass barriers allows them to become bioavailable, persisting in organs and posing long-term health risks. Generally in body, liver and spleen play a role in removing these micro nanoplastics with final excretion in fecus. And coming to the challenges in micro and nanoplastic research include difficulties in sample preparation and extraction from complex environmental and biological matrices because the lack of sensitivity and reliable detection techniques to identify these tiny particles. The wide variability in their chemical and physical properties mainly pose for lack of detection. And generally, we have a limited data on long-term exposure effects, particularly at the cellular and systemic levels. That's why it becomes a major challenge for the detection of these micro and nanoplastic research. Coming to the mechanism of action, as I said before, these micro and nanoplastics can be enter into the body through inhalation or ingestion of food or etc. How these nanoparticles internalize into the body parts and how the cellular response is going to happen. So coming to the mechanism of action, these nanoparticles can cause cell death. I want to show an example of a study. A study was performed to evaluate its effects. In this study, the nanoparticles are treated with keratinocyte cells. These are a type of skin cells to assess the exposure of these nanoplastics. After treating the nanoparticles to these cells, it forms a protein corona formation. These nanoparticles will bind to the cell protein and internalization occurs by pinocytic cup formation. Then lysosomal disintegration occurs, leading to active digestion and release of the nanoparticle additives. After that, the cytotoxic events are observed, mostly by ROS production, leading to cell death. To examine the internalization of these nanoparticles in the cells, they have performed an experiment. In this experiment, they have treated the keratinocytes, that means the skin cells, with fluorescently labeled nanoparticles from the time interval between 12 hours to 144 hours and examined under the fluorescence microscope. In this figure, we can see the cellular uptake, how it has been occurred. This figure showed minimum accumulation of nanoparticles at 12 and 24 hours, and the maximum internalization occurred at 48 hours and 72 hours after the treatment. There was no further increase in particle accumulation observed at 96 hours or 120 hours and 144 hours, suggesting that the interruption in the internalization process. On the other hand, for exclusion experiment, the nanoparticles incorporated medium was replaced with free medium, that is without nanoparticles, after 72 hours of exposure. After 96 hours, we can see the gradual decrease in fluorescence intensity. After 96 hours, we can see the gradual decrease in fluorescence intensity in cells, followed by complete absence of fluorescent cells at 144 hours. This is the fluorescence which we can observe. But after replacing the medium from 96 hours, there was decrease in the fluorescence. It appears that gradual reduction of nanoparticles in cells could be due to rapid exclusion of internalized nanoparticles or also by ROS mediated cell death. We can say that the cells might died or by ROS method, or we can say that the reduction of nanoparticles also decreased the fluorescence. Coming to the global impact, these micro and nanoplastics has a major role in the global impact. The production, migration, and distribution of these nanoparticles in the environment. The plastics are released to the environment during manufacture, usage, and disposal. The environmental plastics can be gradually broken down into micro or nanoplastics, and they can easily diffuse through water or air circulation. And these nanoplastics have been found to be widespread in air, lakes, rivers, oceans, and soils, where they can be taken up by various organisms and also humans. How these micro and nanoplastics are very harmful for the environment as well as human health means mainly by the process of corona formation. What is corona formation? Means the process where the substances like biomolecules, natural organic matter, chemical contaminants, these substances absorb onto the surface of these micro or nanoplastics, forming a corona. Because the micro or nanoplastics have a larger surface area. That's why these substances can easily absorb to the micro or nanoplastics. These can alter the physicochemical properties and have very adverse outcomes. So after the formation of these nanoplastics along with the additives and pollutants, it has more adverse effects on health as well as environment. How to detect these microplastics or nanoplastics? Generally, there are some analytical techniques for the characterization of these micro or nanoplastics and their strengths and limitations. The techniques are as follows, like UV visible spectroscopy, DLS, fluorescence microscopy, TEM, SEM, AFM, EDX, Raman spectroscopy, FTIR, ICP-MS, TOF SIMS, GCMS, LCMS, and CEMS. These techniques are used for the detection of the various information like corona formation in binding of protein corona to micro nanoplastics and their sample states and their strengths and limitations. Coming to the nanomaterials which are used in these cosmetic products have various advantages. The nanomaterials mostly used in these cosmetic products are silicon nanoparticles, titanium dioxide, zinc oxide nanoparticles, silver and gold nanoparticles, biodegradable polymeric particles, nanogels, liposomes, lipid nanoparticles, and some natural nanomaterials. Coming to silicon nanoparticles, these are used as carriers for active ingredients, texture enhancers, and rheology modifiers, anti-caking agents, and as foam stabilizers. They have the advantages like high surface area, and these are biocompatible, sometimes often inert, can be synthesized by green methods from rice husk or agricultural waste, reducing environmental footprint. But the limitations of these silicon nanoparticles include skin penetration concerns when very small, potential oxidative stress depending on surface chemistry, regulatory limits, etc. Coming to titanium dioxide, titanium dioxide is generally and mostly used in sunscreens as a protective cosmetic, helps with coverage and opacity. And coming to advantages, the use is very effective in UV protection, reliably used and studied, well established in manufacture and regulatory understanding. And the limitations include photocatalytic effects. It can generate ROS under UV. So safety under long-term exposure, ensuring particle size, can prevent deeper skin penetration. And zinc oxide nanoparticles, these are also used in sunscreens and anti-UV formulations as an antimicrobial or skin protective agents. The advantages are they have broad spectrum UV protection, minimal transparency when used as a nanoparticles size, and generally it has a good safety profile when properly formulated. And zinc oxide nanoparticles also have the same issues like titanium dioxide. Coming to the silver and gold nanoparticles, they have properties like antibacterial and antifungal functions, anti-aging, and antioxidant roles in creams. So they are used in creams, gels, treatments for acne, etc. And the advantages of these silver and gold nanoparticles includes they are used as a potent antimicrobial agents. Sometimes a lower dosage is needed, and it can be used as a multifunctional agents, example for beauty and also function. And these metal nanoparticles may have toxicity and accumulation concerns, and generally it is more cost. We need to spend more cost for these silver and gold nanoparticles, and these have some toxicity, so environmental concerns are also there for these silver and gold nanoparticles. Coming to biodegradable polymer nanoparticles, these are used as a substituents for exfoliant beads and used as carriers that degrade into non-toxic products And the advantages include biodegradability and the potentially safe breakdown products like sugars and amino acids, and they have good tunable properties. The limitations, coming to the limitations of these biodegradable polymeric nanoparticles, they must maintain mechanical and sensory performance, and it has stability issues during storage and related cost issues and regulatory acceptance. Coming to other nanomaterials like nanogels, liposomes, cubosomes, etc., they are generally used as the delivery systems for moisturizers, and they are also used as active ingredients and antioxidants and for improved skin absorption. Coming to the advantages, they can encapsulate the active ingredients and enhance penetration into the skin, reduce irritation, and allow the release control. Often lower amounts is needed for these nanogels or liposomes. And coming to the limitations of these nanoparticles, the toxicity is depending on the material and size, and it has stability issues, and it has a risk for an unintended penetration or bioaccumulation. And coming to the natural or green nanomaterials, the examples include lignin nanoparticles, biogenic silica, and clay-based nanosheets. The use of these green nanomaterials would be for UV protection, antioxidant function, rheology, or thickening, are used as a thickening agents and carriers. The advantages of these green nanomaterials is like these are the renewable sources, often have lower effects on the environment, and may offer multifunctional benefits like it can be used as an antioxidant agents and lowering the UV protection, etc. Limitations of these green nanomaterials includes they have more impurities, and manufacturing methods and are less standardized, and sometimes it has a shorter shelf life. Generally, these cosmetic products uses natural ingredients as well as plastic ingredients, raising the concern on the potential risk of the human health. Various types of skincare products which we are using are like anti-aging agents, toners, shaving creams, serums, deodorants, facial masks, exfoliators, sunscreens, cleansing lotions, etc. Main characteristics of cosmetic products in formulation and relative effects on the skin. We use these cosmetic products for purposes like exfoliating. These powders are able to remove dead cells on the skin surface, promoting cell renewal and favoring smoother skin. And they're also used as fixative agents. These powders avoid smudging in semi-solid formulations and prolong their shelf life. Some are used as a mattifying or brightening agents. This can be used to reduce undesirable reflections on the skin or enhance brightness to the face, especially in the T-zone like forehead, nose, or chin, where oiliness tends to accumulate more. And some are used as the oil absorption agents like sebum normalizing products. Same powders helps to control the oiliness, maintaining an opaque and matte appearance. There are various types of organic and inorganic nanoparticles used in skincare products. As I told earlier in the slide, the various types of nanoparticles like liposomes, ethosomes, transforosomes, neosomes, etc. And some are non-vesicular nanoparticles like solid lipid nanoparticles, nanoemulsions, nanocrystals, etc. Coming to the inorganic nanoparticles, they're like gold nanoparticles, silver nanoparticles, titanium dioxide, zinc oxide nanoparticles, silica, copper, and aluminum oxide nanoparticles. And some are like carbon-based nanoparticles, they are fluorine, nanodiamond, and nanotube. And I already discussed the advantages of these nanoparticles in previous slide. According to the environmental health and also environmental concern and also human health, we need to replace these nanoplastics. Generally, these nanoplastics in cosmetics should be replaced because of these concerns, and replacing them with sustainable alternatives is crucial for minimizing plastic pollution and protecting health. Developing new remediation technologies using bio-inspired materials like biochar, plant-based sponges, silica, starch, clays, cellulose or olive oil, etc. These can be a better option for usage in cosmetic products than these micro or nanoplastics. Okay. These nanoplastics or microplastics also combine with the different types of polymers which are environmentally hazardous. Some of the harmful polymers are like PEG, nylon, PPG, PMMA, PES, PET, etc. We can replace these harmful polymers with eco-friendly agents like starch, cellulose, alginate, chitosan, lignin, agar, pectin, etc. Coming to the recent alternatives and innovations in these cosmetic and personal care products, here are some examples used as alternatives. First one is like MIT biodegradable microbeads. These are developed as a biodegradable polymers to replace plastic beads used in beauty cleansers. The key feature of these biodegradable microbeads are they break down into sugars and amino acids, and they are used for better removal of makeup or waterproof cosmetics versus plastic beads tested in the cleanser products. And coming to nature beads, these are bio-based microbeads made from cellulose. It is from the plant-derived cellulose. And the key features of this product is like it is biodegradable and has various sizes and colors, aiming for scale up with plant-sourced raw materials, replacing the plastic exfoliants. University of Minnesota Biomass, they introduced an alternative like biomass microbeads. These microbeads from unmodified biomass like cellulose, combining cellulose and lignin, is used as exfoliant in these products. It is the key feature of this product is it is biocompatible, biodegradable compared to the synthetic beads. These are developed from waste biomass, avoiding the allergens. And another alternative is like biopowders, natural exfoliants. The use of this is these powders from upcycled fruit stones, nut shells like olive pit, almond shell, apricot seed, walnut shell, etc. The feature of these powders is it doesn't consist of chemicals and it has multiple particle size options and it has safe texture, upcycling the agricultural waste. The another alternative is Teisha Technologies. They use a biodegradable polymer material from natural feedstocks. It is from farming or food waste intended to replace many microplastics in cosmetics. The feature of this is it is certified biodegradable matches and it has a potential large scale reduction of microplastic load. And another alternative is Shin Etsu silicones like elastomer gels. These elastomer gels, they gave some examples like KSG 16SF, KSG 19PF, KM116, etc. These replaced microplastics for soft focus, thickening, texture, matte or powdery feel in cosmetics. The feature of these elastomer gels offer sensory performance similar to microplastics like powderiness or soft focus, good compatibility with formulations, etc. And these are microplastic free. And the another alternative is like Eastman Esmeric CC1N10. It is the use of this is they use cellulose ester micropowder for use in lipsticks, pressed powders, foundations instead of the synthetic microplastics. The key feature of this material is it is microplastic free, derived from sustainable wood pulp. It has good compressibility and delivers optical or pigment dispersion and natural matte finish. Generally, these nanoplastics are non-degradable polymers that take hundreds of years to decompose. Due to their smaller size, they cannot be collected and recycled, but pollute the world's ecosystem, especially in our oceans, lakes, rivers, etc. And a considerable part is absorbed by marine animals and ends up in our food chain. And also it has a major impact on the human health. Why these microplastics or nanoplastics need to be replaced is most visibly these microplastics or nanoplastics are contained in wash of products such as shower gels or face masks to create an exfoliating effect. These polyethylene or polyurethane particles are easy to detect, whereas others go unnoticed by consumers because they cannot be identified as such at a glance. Here is a brief overview of common microplastics and their main functions. The examples are polyethylene nylon 12 or nylon 6. It is used as a bulking agent, stabilizer, and rheology modifier. Polybutylene terephthalate, it is used for film formation and viscosity modifier. Acrylates copolymers, these are used for binding or suspending agents. Allyl stearate or vinyl acetate copolymer, it is used for film formation and as hair fixative. And butylene ethylene styrene copolymer, it is used for viscosity control. And styrene acrylates copolymer, it is used for color flakes for makeup products. And trimethyl siloxysilicate, it is a silicone resin which is used in film formation, mostly in sunscreen products. Replacing these chemicals with natural agents like biodegradable exfoliators. Like these exfoliators are used generally for exfoliating the dead skin. The natural scrubs like grain from the sponges or from the fibers, we can use these natural ingredients than those chemicals. Bulking agents, cosmetic fillers, and texturizers. For this, the natural agents like lignocellulosic powders made from upcycled olive stones and other sustainable raw materials can be used than these microplastics. And natural pigments or pigment carriers. The fine powders made from 100% fruit shells, as I said in the earlier slide, they can be used for the toning of the products in the makeup products. They're the residues that are from the fruit processing or oil producing industries, which means that the production reduces the waste while creating a new value chain. That means the waste can be recycled and it is a natural method which is not affecting the health. Examples of these, some of the natural powders include almond shell powder, apricot stone powder, argan shell powder, olive stone powder, pistachio shell powder. They have some advantages which I mentioned in this slide, and we can use as an alternative from those plastics. And some of the microplastics which are used in these cosmetic products will be polyethylene, polypropylene, polymethyl methacrylate, etc. and their formulation effects. They are mostly used in emulsifying hair and skin conditioning and film forming, hair and skin conditioning for opacifying and texturing, etc. Polyethylene is one of the most widely used synthetic polymer, and it is easy to produce, and it consists of repetitive units of ethylene groups which give the polymer flexibility and strength. Indeed, the relative polymerization can yield branched or linear structures leading to the production of high density polyethylene and linear low density polyethylene, each contributing to different performances. In cosmetics, this polyethylene is a film forming and viscosity regulating agent. Specifically, polyethylene microparticles were used in formulations for facial and body scrubs as an exfoliating agent. But from 2018, they have been banned from cosmetic products due to their impact on marine systems. Coming to polypropylene, it is a thermoplastic homopolymer produced from 1-propene. It is a gas derived from petroleum and natural gas. Polypropylene is known for its lightweight nature and resistant to corrosion, wear, and moisture. This polymer is used as a viscosity controlling agent in foundations and nail polishes, also employed as an exfoliant in some formulations. And coming to PMMA, it is a transparent thermoplastic polymer obtained from methyl methacrylate. In cosmetics, this polymer is used in nail polish, lip gloss, and mascara due to its film forming aptitude. The PMMA microparticles are also used as absorbent agents for transporting active ingredients and as brightness or mattifying regulators, reducing imperfections caused by aging. Additionally, they modulate the texture of formulations due to their smaller size. Coming to PTFE, it is a homopolymer derived from the polymerization of tetrafluoroethylene. This polymer is used as hair conditioning and additive in makeup products, including foundations, face powders, and primers to offer a matte finish. PTFE microparticles can enhance the sensorial experience of cosmetic formulations by improving the texture with a smooth and silky sensation. Additionally, they exhibit non-sticky, free-flowing, moisture-resistant, and long-lasting properties, which will suit for most products. And polyethylene terephthalate is derived from terephthalic acid and ethylene glycol. These PET microparticles can be utilized in various formulations due to their properties. They can enhance the texture of semi-solid formulations and serve as exfoliating agents in skincare products like face and body scrubs. Additionally, they can function as mattifying agents in creams, lotions, and foundations. These microplastics can be used also to deliver and release active ingredients. In addition, they can be colored and used as additives in the formulation of leg and body paints, nail polish, lip gloss, and hair coloring products. Coming to polyamides, these are synthetic polymers containing amide bonds. As repeating units and various types can be obtained based on the starting monomers. Eminent examples are nylon 6 and nylon 12. The first one is derived from the ring opening of caprolactam, serves as a viscosity controlling, bulking, thinning, and moisturizing agent. Nylon 12, a synthetic polymer derived from aminoluric acid monomers, possesses bulking and opacifying properties and is commonly found in skin creams and face powders. Coming to polyacrylates, these are a family of synthetic polymers made up of acrylate monomers, which are used as film forming, antistatic, binding, hair fixative, and suspending agents. These are generally used as a binding agents, emulsion stabilizing agents, thickening agents, and for film forming and opacifying agents. Coming to polymethyl icyl sesquioxane, it is a synthetic silicon obtained from the hydrolysis and condensation of silicon methyl trimethoxysilane, and this synthetic polymer is used for film forming, texturing, opacifying skin and hair condition. And polyurethane is a synthetic polymer made from the reaction between polyols and diisocyanates. In cosmetics, these polyurethane microbeads are used as exfoliating agents for texture enhancement and as binding agents. They are capable of absorbing excess sebum from the skin, making them useful in oil control formulations. And polyurethane can also be used as a color additive to enhance the effects in products such as nail polish, lip gloss, and eyeshadows. An example of this polyurethane is cross-polymer 1, a synthetic copolymer made of isophthalic acid, adipic acid, hexylene glycol, neopentyl glycol, isophodiazonate units, which is used as binding, film forming, and hair fixing agents. And coming to PEGs and polypropylene glycols, the synthetic polymers of ethylene glycol is broadly used in pharmaceutical formulations for drug delivery, and they are also employed in cosmetic products as humectants or emulsifiers formulated as creams, lotions, and serums. These are soluble in aqueous and organic phases, favoring in solubilization of active ingredients and fragrances in formulations. Other microplastics of common usage are polybutylene, terephthalate, polystyrene, and various types of nylon, acrylates, and polyurethane cross-polymers. And these are some of natural alternatives which can be used to replace the microplastics. Like the names of them are like starch, alginate, chitosan, lignin, and these are the chemical structures of those natural alternatives. Coming to the global emerging trends in nanocosmetics formulations. The emerging trends in nanocosmetic formulations includes advanced nano carriers, targeted ingredient delivery, personalized skincare, environmental friendly methods, and also follows the safety and regulations. And the application of these nanomaterials in the formulation of cosmetics and other products for topical application and their interaction with everyday human activities. Nanomaterials used in hair and skincare products promote quality of life by offering innovations in a range of applications and enhance sunscreen protection. These nanomaterials are also used as delivery systems for a range of active pharmaceutical ingredients to treat several skin pathologies. And the nanomaterials used for encapsulating APIs, like active pharmaceutical ingredients, are for the applications mainly used by these nanomaterials is for improved solubility and bioavailability, controlled and sustained release, for targeted delivery, and for protection of the active pharmaceutical ingredients and crossing biological barriers, enhanced stability, and multifunctionality. Some of the active pharmaceutical ingredients names are like naringenin, tretinoin, epigallocatechin gallate, indomethacin, and resveratrol. These active pharmaceutical ingredients can be formed into formulations like nanoemulsions, liposomes, carbon nanotubes, dendrimers, etc. And these are the applications of these nanomaterials. And different delivery systems which can be used in cosmetics are like these hydrogels, cubosomes, nanocapsules, nanocrystals, etc. Some include liposomes, nanoemulsions, solid lipid nanoparticles, etc. But they also have some side effects like nanotoxicity because of the properties like smaller size, shape, surface area, and cellular toxicity. Due to the smaller size and having larger surface area, they can induce more reactive oxygen species, and they can reach the bloodstream and organs and initiates inflammation, and they can be a reason for causing cytotoxicity, mutagenicity, and genotoxicity. These are some nano-based anti-aging products which can be used in the cosmetic products. These are the brand names and the characteristics of these brand products and uses. And some of the, as I said, we need to replace these nano or microplastics with natural materials. These are examples of the nanomaterials which consist of the active ingredients and their applications. Recently, some nanosomes are prepared by DS laboratories. The active ingredients of these nanosomes includes plant extracts and oils like almond oil, lavender oil, etc. And some natural compounds like caffeine, amino acids, and polyphenols with high cationic charge density. This enhances the deposition of functional active ingredients and fragrances at target site and reduces wash off during rinse. One of the example of these nanosomes is Veterol. It is a cream used for wrinkles and fine lines. And another product is Revita shampoo. It is used for anti-hair loss and hair follicle stimulation. The other natural ingredients which are combined to use as a nanomaterial is liposomes. The brand and producer of this product is Rovi Cosmetics. The active ingredients of these liposomes include coenzyme Q10 and vitamins A, C, and E, and green tea extract. It showed enhanced sun protection and antioxidant effect for active ingredients. Example of this liposome is Rovisome ACE+, Rovisome Defense, Rovisome Q10, etc. The another type of liposomes used as an alternative is coenzyme Q10. It enhances antioxidant, anti-wrinkle, and penetration properties, as well as collagen and elastin production of connective tissue. The producer of these liposomes is Ivan Naturals. And some of the natural extracts and oils are combined and formulated as liposomes. These liposome encapsulation improved natural products delivery to target site with higher antioxidant activity and skin hydration. The brand was this product was produced by Russell Organics. And the other formulation of liposomes consisting of the active ingredients with vitamin E, hyaluronic acid, superoxide, dismutase, and sunflower oil. The use of this encapsulated vitamin E and hyaluronic acid increases skin protection to sun damage and oxidative stress. This is used as a liposome face and neck lotion. This is produced by Clinicians Complex. And coming to the other replacement includes plant extracts, oils, and the major application of this is skin regeneration and providing anti-inflammatory and anti-scaling activities. The other nanomaterials which were formulated as nanoemulsions and nanocomplexes with titanium dioxide, zinc oxide, gold nanoparticles, and nanospheres. The active ingredients and applications are mentioned in this table, and these are the brand or producers of this type of natural alternatives. And coming to the advantages and disadvantages of nanosystems in cosmetic formulations. These are the pros and cons. Coming to the pros, the nanoparticles in cosmetics increase the efficiency of the products and shelf life of the products. And the liquid nanoparticles based on phosphatidylcholine are readily biodegradable, and small size droplets with high surface area, which allows effective transport of the actives to the skin, and provides enhanced properties such as UV protection, deeper skin penetration, and improved hydration. The cons include these are established as nanohazards, the high reactivity of nanomaterials because of higher surface to volume ratio, which gives rise to toxicity. And reactivity of these nanoparticles can result in the formation of reactive oxygen species which affect the macromolecules present in the cells such as proteins, DNA, even the cell membranes. And the absorption of nanoparticles through the skin or inhalation of sprayed cosmetics is another cause of concern. And those are time-consuming techniques required for the formulation. And thank you everyone. And I'm expressing my gratitude to Dr. Saraswati Garu for giving me this opportunity. And also, I express my gratitude for her valuable support and guidance. And I want to express my heartfelt thanks to all the faculty members and management. Thank you.
Yeah, thank you, ma'am. Thank you, Dr. B. Anantha Lakshmi ma'am, for your dedication and well-mannered presentation. Even you are passing through a difficult time. So, if possible, let us take a photo. If you
Yes,
switch on video.
Yes, ma'am. Yes, ma'am.
Even all the participants, kindly unmute the video. Kusma, done? Kusuma? Hi, Kusuma.
Yes, ma'am, taking these shots.
Yeah, thank you. Thank you, ma'am. Now let us invite Mr. J. Dixit Kumar to deliver vote of thanks for this session. Sir Dixit, sir.
Am I audible, ma'am?
Yeah, okay. Yeah, audible. Continue, sir.
Yeah. A special thanks to Dr. B. Anantha Lakshmi for her excellent session on nanoplastic replacement in cosmetics and personal care products. The futuristic directions you highlighted were highly valuable. I also thank everyone who contributed meaningfully for the discussion. Thank you. Thank you very much.
Thank you, sir. Thank you, Dikshit, sir. And thank you, ma'am, Saraswati, ma'am, for giving me this opportunity.
Thank you, ma'am. Thank you for a wonderful session. Yeah. So now we may leave this session. Thank you, dear participants. If any queries, we can, but no queries. I think they understood your situation, maybe. So thanks on behalf of KPRIT College of Engineering. My sincere thanks to all participants and resource persons and also higher authorities, to our beloved director, our committed principal sir. Thank you for this opportunity to conduct online FDP program. Without their support, it may not possible. So almost 4 days successfully conducted. Let us see for the next 2 days. So thank you, one and all.
Thank you, ma'am. Thank you so much.
Yeah.
Thank you, ma'am.
Yeah. Thank you, sir. Now all participants may leave this session and kindly share the PPT.